Everyone. Today we're going to be continuing our notes on 4.5, solving exponential and logarithmic equations, but now we're going to learn a new method, solving by factoring. Let's look at this first example, e to the 2x minus e to the x minus 6 equals 0. Now at first this might look complicated, but what we can think of this problem as is similar to the quadratic trinomial x squared minus x minus 6. This looks very similar, except the only difference here is that instead of the variable x, we have the variable e to the power of x. Notice that e to the 2x is the same thing as e to the x, the quantity squared. So we can replace these x's with e to the x's. Now I know how to factor this quadratic trinomial. This factors to x minus 3 times x plus 2, the quantities. And if we set that equal to 0, then we get solutions x equals 3 and x equals negative 2. We're going to do the same thing here, but now with this exponential equation. So this factors here to e to the x minus 3 times the quantity e to the x plus 2 is equal to 0. Again, just as a reminder, we're looking for factors of negative 6 that add to negative 1. Those factors are negative 3 and positive 2. Okay? So using the zero product property, we can set each of these factors equal to 0. So then we get e to the x is equal to 3, and e to the x is equal to negative 2. Now, if we were to rewrite these as logs, we would get the natural log of 3 is equal to x, and the natural log of negative 2 is equal to x. Now, we'll start with the left-hand side. X equals the natural log of 3. If we're looking for an exact answer, this would be the exact answer, the natural log of 3. For a decimal approximation, go ahead and take out your calculator. And go ahead and hit Control, and then e to the x, that's going to give you the natural log of 3. So I'm going to hit 3, and then Control-Enter is going to give me a decimal approximation of 1.099. So x is approximately 1.099. Okay. For this other equation, here we have x is equal to the natural log of negative 2. Now, remember the domain for all logs, right? Parent functions, log base anything, log base b of x. The domain is all positive numbers, x greater than 0. Because the argument of this log here is negative 2, this is outside the domain of the natural log. Therefore, this equation has no solution. All right, so this equation does not have a solution from this factor. So the only solution is x equals the natural log of 3. All right. Number 2, here we have 3x times e to the x plus x squared times e to the x. Okay. The first thing that we should always check for, especially when factoring, is a GCF. Does this expression on the left-hand side have a GCF? Yes, this does. They both have e to the x terms. In fact, they both have x e to the x terms. So let's go ahead and factor that out. X e to the x. And what's left inside in the first term is just 3. And what's left in the second term is just one of those x's. So we factored out the other x, and we factored out the e to the x. And this is equal to 0. Okay? So what we can do then, again, zero product property. This is similar to saying x times e to the x times the quantity 3 plus x. Each of these factors we can set equal to 0. So x equals 0, e to the x equals 0, and 3 plus x equals 0. So we get solutions. Well, x equals 0. E to the x equals 0 is natural log of 0 is equal to x, which we'll talk about soon. And then x is equal to negative 3. All right, so let's check and see if any of these are extraneous. X equals 0 is a solution. You can plug in e to the 0. That evaluates to a real number. That number's 1. You can square 0. You can multiply anything by 0. That's totally fine. X equals 0 is a solution. X equals the natural log of 0, however. Again, the natural log has the domain x greater than 0. 0 is not part of the domain of the natural log or any parent function for a log. Therefore, this equation does not yield a solution. And finally, x equals negative 3. This here is a solution. You can plug in negative 3 and square it. That's a real number. E to the negative 3, that's totally fine. That's 1 over e cubed, right? And you can do that over here as well. So negative 3 is also a solution. So we have two solutions here, 0 and negative 3. All right, let's get some more practice. Number 3, So this looks similar to number 1 in that we have e to the power of 2x and we've got an e to the x. So again, looking like a quadratic trinomial, I'm going to look for factors of positive 2 that add to negative 3. The answer is negative 2 and negative 1. So this factors to e to the x minus 2, e to the x minus 1 equals 0. And so we set each of these equal to 0. So we get e to the x is equal to 2, e to the x is equal to 1, or the natural log of 2 is equal to x, or the natural log of 1 is equal to x. And in fact, both of these have these are both solutions. So these are our answers, but let's go ahead and get a decimal approximation. So the natural log of 2, control enter, 0.693. And then also the natural log of 1, control enter, and we get 0, of course. Okay. All right, number 4. This is multiplication here, this symbol here. So this is saying 2 times 10 to the x. First thing we're going to do is get this equal to 0. So I'm going to subtract that quantity, 2 times 10 to the x. Okay. So what we have is x squared 10 to the x minus x 10 to the x minus 2 times 10 to the x. Okay, and this is equal to 0. All right, I notice that we have a GCF of 10 to the x. So when I factor out the 10 to the x, what's left over is x squared minus x minus 2, and that's equal to 0. This quadratic trinomial factors to x minus 2 and x plus 1. And so we set each factor equal to 0. We get 10 to the x is equal to 0. We get x is equal to 2 and x is equal to negative 1. Each of these here, x equals 2 and x equals negative 1, are solutions. So we can plug those in, square them, raise them to those powers. That's totally fine. However, this last equation here, 10 to the x, this is an exponential equation. If you were to think about the graph of this function, this has a horizontal asymptote at y equals 0. This function, there's no quantity that we could raise 10 to that power and get it equal to 0. We can get really close, but not equal to 0. So this equation right here has no solution. Okay. Number 5, here we have 4 to the x times e to the 2x minus 4 to the x times e to the x equals 2 times 4 to the x. So again, we're going to set this equal to 0. So 4 to the x, e to the 2x minus 4 to the x, e to the x minus 2 times 4 to the x. And that's all equal to 0. Again, another GCF. This one is to the 4 to the x. And so we're left with e to the 2x minus e to the x, and then minus 2. And this is equal to 0. Okay? So similar to those quadratic trinomials, we have 4 to the x times the quantity e to the x minus 2 and e to the x plus 1 equals 0. So we have the three equations. 4 to the x equals 0, e to the x equals 2, e to the x equals negative 1. Okay? So for the middle one, we get x is equal to the natural log of 2. That's totally fine. 4 to the x equals 0. We just talked about a similar problem, 10 to the x equals 0. This does not have a solution. And likewise, e to the x equals negative 1. E to the x, the range is all positive numbers. So this equaling negative 1 can't possibly have a solution. Okay. Again, you could rewrite it as a log. X equals natural log of negative 1, where that negative 1 is outside the domain of the natural log. All right. All right, so number 6, here we go. This one's a little bit tricky. Here we have 4 to the x times log base 6 of 2x minus 3 minus 32 times log base 6 of 2x minus 3. And this is already equal to 0, so nothing to move around here. Now, first thing I notice here is that we have log base 6 of 2x minus 3 in both of these terms here. Down to the argument, these are exactly the same. So I notice that we can factor out the GCF of log base 6 of 2x minus 3. And what's left over is the quantity 4 to the x minus 32. And this is equal to 0. Okay? So using the zero product property, we have this log times this grouping here equals 0. So we have log base 6 of 2x minus 3 is equal to 0. And 4 to the x minus 32 equals 0. So on the left-hand side, we have 6 to the 0 is equal to 2x minus 3. I'm going to go ahead and write out that step. Or in other words, 1 equals 2x minus 3. If we add 3 to both sides, we get 4 equals 2x, or x equals 2. Okay? And, I'll go ahead and write out that intermediate step as well. 4 equals 2x. Okay? So x equals 2. Now we have to go back and check, does this cause a domain error? 2 times 2 minus 3, is that positive? Yes, it is. So this is totally fine. For the other equation, add 32. We get 4 to the x is equal to 32. Or rewriting this, log base 4 of 32 is equal to x. This is, let's see, rewriting 32 as a power of, we'll say 2. This would be 2 to the 5th. Or 2 could be rewritten as the square root of 4. So this could also be rewritten as 4 to the 1/2. So this would be log base 4 of 4 to the 5/2. So then x is equal to 5/2. Okay. At this point, you could have also just plugged it into your calculator, the log base 4 of 32, and you'll get 2.5 or 5/2. Okay. So a summary of the strategies that we're going to try here. The first things first, we're going to set the equation equal to 0. Set it equal to 0. Okay. Step 2 is to condense as much as we can. Okay. Condense as much as we can. Next, we're going to look to factor. So always check for a GCF. And then step 4, we're going to use the zero product property. Right? So if A times B equals 0, then A equals 0 or B equals 0. Okay? And then solve. And then I'm going to just put a note, check for extraneous solutions. All right? So set it equal to 0, get everything over to one side, condense any logs or exponentials wherever you can. That might involve rewriting some exponentials, some bases in terms of another base. So like if it's like over here, we had a power of 2, but I rewrote that as a base 4. So that would mean 4 to the 1/2 is 2, right? So rewriting things so that some things cancel out is always a great strategy. Next up, we factor. Always check for a GCF first, but then it could also mean like factoring a quadratic trinomial. Remember those special cases, differences of squares and perfect square trinomials. And then finally, zero product property and solve. Okay, set each factor equal to 0, solve each of those equations. Don't forget to check for extraneous solutions. We're going to get a lot of practice. This was our notes on solving by factoring. We'll see you tomorrow. Have a great day, everybody.